Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important topic, that is the Brownian motion. Already in 1828, a botanical scientist, a botany scientist Robert Brown introduced this phenomena for while using a Brownian particle immersed in the water. A motion is coming of that particle, so that particle motion we call it as a Brownian motion. After some time, Einstein take this theory and he derived the theory and he explained and he derived the mobility and diffusion of coefficient of the Brownian motion particle he derived. So that is entirely different story, because in theory I told you in our app, but according to canvassing of our institute, I have to take for each and every topic one question I am discussing, I am uploading in our YouTube channel. This is a direct class, I am not editing anything to you. So whatever the class I am taking, directly I am uploading on YouTube. So please try to understand, sometimes voice is not clear. So whatever is there, any disturbance is there, also you have to try to adjust. One Brownian motion question came in the previous CSIR bits, PYQs. Once you have to see CSIR June 2015. CSIR June 2015, once you able to see a large n number of Brownian particles in one dimension. What they are giving? A large n number of particles, where it is there in one dimension is there. Start their diffusion motion. So that's why there is a diffusion equation is there. What is the diffusion equation? Dou n by dou t is equal to d into dou square n by dou x square. So this is the diffusion equation, correct? So from the origin at t is equal to 0, d is a diffusion coefficient, where d is the diffusion coefficient, right? So the number of particles crossing the point at a distance L from the origin. So therefore you have to take it x is equal to L and at t is equal to 0. At t is equal to 0, origin L from the origin, that is the origin means at t is equal to 0 per unit time. Depends on L and t. So at t is equal to 0, that is the origin, it is starts from the distance x is equal to L. So the particle crossing the point, you have to take it as a at t is equal to t also you have to consider. Now what they want to ask, the number of particles crossing, the number of particles n x comma t is equal to how much they are asking. But x is equal to what is that? N x L comma t is equal to how much they are asking. But you know that the solution of the diffusion equation for one dimensional, what is the solution of the diffusion equation? N of x comma t is equal to n number of particles, that's why n is divided by square root of 4 phi dt exponential of e to the power of minus x square is divided by 4 dt. But at x is equal to L, here you have to take at L comma t is equal to n L comma t is equal to n is divided by square root of 4 phi dt into e to the power of minus L square is divided by 4 dt. So just you have to simply you have to apply, so you will get the answer. What is your answer? Among the options, option A is correct, n by 4 phi dt square root of 4 phi dt e to the power of minus L square by 4 dt. NL is not wrong, 16 phi is not wrong, n into e to the power of minus 4 dt by L square also not wrong. So not correct, clear? So because you have to see, your correct option is n by square root of 4 phi dt into e to the power of minus L square by 4 dt. That is the solution. How it will come? You know the diffusion equation. What is your diffusion equation? Dou n by dou t is equal to d into dou square n by dou x square. If you solve this diffusion equation, For one dimensional you are going to get it this one. For 3 dimensional it is the different thing, but 1 dimensional, because our Brownian particle is moving 1 dimensional start only, that is why we have to take that one only. Clear? Like this we have to do in our competitive examination. Only one topic left behind, that is the introduction to non-equilibrium processes. If there any question is there among the set or net or gate or whatever it may be, those question I will give to you. So, this is the almost last topic according to statistical physics. Already every video I am informing you, we started the CSIR and GATE online physics coaching we started. We have one app, that is Quantum Online Academy app. So, not only that, they according to the content of the JL and giving the same classes I am uploading here. So, that is why you want to take here. If you want to negotiate with me, you have to negotiate with me. My mobile number is 9908437460, right. So, once you have to download our app, you able to see the courses. CSIR and GATE physics course will appear like this, JL physics course will appear like this, DL physics course will appear like this. Not only that, the individual papers also will apply like that. So, what are the individual papers? Mathematical methods of physics we finished till now, and classical mechanics also completely we finished, that individual papers also available. Electromagnetic theory also completely finished, quantum mechanics also completely finished, thermodynamics and statistical mechanics also completely finished. So, till now these 5 papers we are finishing completely. Our app complete portion is there according to JL or DL or CSIR or GATE, whatever the syllabus it may be. So, complete portion is available in our app. These 5 papers are finished. So, after that I have to start with the nuclear and particle physics. I have to start nuclear and particle physics. So, later I am coming into the atomic and molecular physics. This is the first one. This paper is 9th according to your syllabus. This paper is 8th, and so we will start with the your 7th paper is condensed matter physics, and your 6th paper is electronics. So, these papers we are going to be start one by one. Maybe it will take after 6-7 months we have to finish the entire the portion. Maybe the next year, maybe 2 years I am teaching to you. So, please try to understand, no teacher can teach 2 years in app in the single course. Only single teacher, nowhere you will get it to teach entire the portion of the CSIR. No teacher will be available in the globe itself also. So, that is why all papers I am only teaching, because myself I want to keep that to teach the all the papers. That is why I kept this one. If you really like, if you really get it our subject to your brain, then only you have to purchase. Otherwise, just you have to listen in our YouTube channel classes only. So, please share and subscribe and like our YouTube channel. Thank you so much.